Hello students, welcome to my class. In this video we are going to be discussing about Newton's law of gravitation problems, relation between small g and capital G problems we are going to be discussing. Let us see the first question. Two spherical balls, each of mass is given as 10 kg, are placed 100 meters apart. The gravitational force of attraction between them they are asking. Here it is given as one is 10 kg mass and here it is one more 10 kg mass it's given, and these two are separated by distance 100 meters is given. And now the gravitational force of attraction between these two masses is, according to Newton's, F equals, we can write it as G m1 m2 by, you can write it as r square you can take, and here you know the gravitational constant value, that is 6.67 into 10 power minus 11 Newton meter square per kg square. Masses is given as 10 kg into 10 kg by, here you can write as r is given as 100 meter whole square, that is nothing but 10 power 4 will be getting, and here 100 and here 100 gets cancelled. When it comes to the numerator it becomes 10 power minus 2, so the force of attraction value will be getting as 6.67 into 10 power minus 13 newtons will be getting. So second one is the correct answer. Now let us see the next question. Here the mass of the moon is given as 1% of the mass of the earth. The ratio of the gravitational pull of the earth on moon to that of the moon on earth they are asking. So here mass of the moon is 1% of the mass of the earth is given, and here if you are taking, this is the earth you are taking, and here moon you can take. There's a moon, you just imagine, and here the ratio of the gravitational pull of earth on moon to that of the moon on the earth will be there asking. Means here according to universal law of gravitation, here with what force the moon is pulling the earth in the sense, here let us take it as F in the sense, here earth also it's going to be pulling the moon with the same gravitational force will be getting. So forces ratio F equal to will be getting a G m mass of the earth into mass of the moon by, you can take as distance, you can take as some r square you can take, and here this is a force experienced by the moon on the earth you are taking. In the same way, force experienced by the earth on moon also, here will be getting a G capital M into M mass of the moon by, here we can get it as r square. So both the things will be same magnitude will be getting, so the ratio will be getting as 1:1 will be getting. Let us see the next question. Two particles of masses is given as 1 kg and 2 kg are placed at a separation of 50 centimeter. Assuming that only here forces acting on the particles are their mutual gravitation. Find the initial acceleration on the heavier particle they are asking. Now here are two masses is given as 1 kg and 2 kg. This is, here you can declare this is 1 kg and 2 kg it's given, and these two are separated by distance is given as 50 centimeter. Now here it's a separation is 50 centimeter, assuming that only forces acting on the particles are mutual gravitational forces. Now here you can take the force of attraction between these two masses will be F equals to G m1 m2 by, here you can take as r square you can get. So here G value will be getting as 6.67 into 10 power minus 11. Masses is given as 1 kg into 2 kg by, here a distance of separation will be getting as 50 centimeter, you have to convert 10 power minus 2 whole square you are getting. Then here find the initial acceleration of the heavier particle they are asking. So heavier particle in the sense, here you can get it as 2 kg mass, it's nothing but F equals, you can take it as m2 into a you can take, which is nothing but, here you can simplify this one, 6.67 into 10 power minus 11 into will be getting as 2 by, here you can cancel this one 10 power minus 1, and here 5 square in the sense 25 will be getting into, here will be getting as 10 power minus 2, and mass m2 is given as 2 is given 2 into a, which will be equal to 6.67 into 10 power minus 11 into 2 by, here you can get it as this is 10 power minus 2 and here 10 power minus 9 will be getting, here you can write it as 10 power minus 9 by 25 you can get, and this 2 gets cancelled. Then here acceleration value will be getting as nearly it's a 2.67 into 10 power minus 10 will be getting. So when you are simplifying this one, here this is 10 power minus 9. So here 1 by 25 in the sense, here you have to take as 0.04, 6.67 into 0.04 into 10 power minus 9 you can take. And when you are taking this value 6.67 into 4 into, you can take as, this is 10 power minus 11 will be getting. When you are simplifying this one, here nearly will be getting as 2.67 into 10 power minus 10 meter per second square you are getting. So first one is the correct answer. Let us see the next question. The next question says here, the gravitational force of attraction between the two bodies is given as F is given. If the mass of each body is doubled and the distance between them is halved, then the force between them there will be, they're asking. So initial gravitational force between the two bodies, let us take as F equals to G m1 m2 by, you can take as R square you can take. Now here F dash, when you are talking here G into, here it is given as mass of each body is double is given. Then here m1 it becomes 2m, and here 2m1, m2 it becomes 2m2 you can take, and here it will be distance between them is halved, means here it becomes r by 2 whole square you can take. Then f dash, which will be equal to 2 2s are 4 will be getting, in the denominator will be getting as r square by 4, 4 into 4 will be getting as 16 will be getting, 16 into will be getting as G m1 m2 by, you can get it as r square you are getting. That means f dash value will be getting as 16 times of the force value will be getting. F dash equal to 16 times of f. So this is the correct answer. Let us see the next question. You are giving total mass is m. How do you divide it into two parts so that gravitational force between them at a given distance will be maximum? So here a mass is given as m is given, and here you are going to be divided into two parts. Let us take an example, students. Here if I am taking as, if mass here, if I am taking as 10 kg mass, if I am taking, if I am dividing like 1 kg into, here it's a 9 kg. Now here the product will be getting as 9, and if you are dividing into 2 kg into 8 kg, here it becomes 16, and here if you are dividing into 3 kg into 7 kg, and here it becomes 21, and 4 kg into, here will be getting as 6 kg, then product it becomes 24, and if I am dividing as 5 kg and 5 kg, now it becomes as 25 will be getting. Again the probability next will be getting as 6 kg into 4 kgs, again here 7 into 3, like that will be getting. So among these 5 probabilities, here the product value will be getting as maximum, you will be getting as, if you divide the total mass into equal parts. Means here according to universal law of gravitation, F is directly proportional to, will be getting as m1 m2. If this product will be higher in the sense, the force of attraction also will be getting as maximum will be getting. So here the mass m is given, and here if you are dividing into equally, that means here like how like 10 kg you are dividing into 5 kg and 5 kg, you are getting as product value will be maximum. If I am dividing the total mass into m by 2 and m by 2, so that the force of attraction will be getting as maximum will be getting. So the answer will be fourth option. Look at the next case. Here gravitational force between the masses m1 and m2 is given as F is given. Here two masses is given, m1 and m2, and the gravitational force of attraction between these two masses is given as F is given. That is F equals to G m1 m2 by r square you can get. Distance of separation you can take as some r you can take. Now here if the third mass m3 is placed nearby m1 and m2, then the force of attraction between m1 and m2 will be. So somewhere here you are placing on mass here m. So here now what is the gravitational force of attraction between the m1 and m2 they are asking. We remember, students, gravitational force will be independent of the medium. Gravitational force of attraction does not depend on medium particles or medium you can take. Here though you are introducing the m3 or m4 or something else, here how much force initially it's going to be experiences, the same force is going to be experiences though if you are introducing the m3 value. So there is no change in force of attraction between the masses m1 and m2. So the answer will be third one will be getting equal to FL1. Let us see the next question. If the distance between the Earth and Moon were doubled, and then the gravitational force between them will be there asking. Earth and Moon they have given. Here the gravitational force of attraction between the Earth and Moon will be G. Capital M is the mass of the Earth, you can take. Small m is the mass of the Moon, you can take. By distance of separation, you can take as some r square, you can take initially. Now if the distance between the Earth and Moon were doubled, now here f dash which will be equal to G into capital M into small m by r. In the sense here you are going to be increasing twice, you are going to be increasing, and the gravitational force will be there asking. So instead of this one here you can take as 1 by 4 into G capital M into small m r square is nothing but initial force will be getting. So here f dash now it becomes the f by 4. So here it is reduced to 1/4 of the initial value when you are increasing the mass of the Earth and mass of the Moon. And here it is given as two spheres of masses is given as small m and as well as capital M are situated in the R is given. Gravitational force between them is given as some F is given. F equals here you can take as G small m into capital M by you can take as R square you can take. Now the space around the masses is now filled with the liquid of specific gravity M. So here the space around the masses here you can take, here you are going to be filling with the liquid, right, of specific gravity is given as here it's 3 is given. So now the gravitational force now will be there also. Here be remember students, here gravitational force is independent of the medium. So it's independent of medium. So it does not affect this medium. So final force of attraction also will be getting as same will be getting. Let us see the next question. The next question says two particles of masses is given as 4 kg and 8 kg are kept at x equal to -2 meter and x equal to +4 meter. It's given. And here one mass is given as here it is at -2 meter. This is an origin you can take. One more mass here at -2 meter you are placing 4 kg mass you are placing, and this is an origin you can take. And here next here will be getting as at 4 meter distance. This is at 4 meter distance you can take, and this is 2 meter and this is 4 meter distance. Here you are placing say an 8 kg mass you are going to be placing. Now the net gravitational force acting on the third particle of mass 1 kg kept at the origin is, at the origin you are keeping 1 kg mass. Now what the force of attraction between these two they are asking. So distance of separation between these will be getting as 2 meters and between these will be getting as 4 meters will be getting. So here you can take this 1 kg mass can be attracted by this 4 kg mass along this direction. Let us take it as F1. And 1 kg mass can be attracted by 8 kg mass towards right side will be getting. So that let us give the name as F2. Now the net gravitational force in the sense here you can take it as, so distance will be less in the sense here between these two masses, here force will be more will be getting. So let us take it as here magnitude of the resultant force will be F1 minus F2. F1 how much will be getting in this one? G into M1. Mass will be 1 kg and here it will be 4 kg. By distance of separation you can take as 2 square. Distance is a scalar quantity, don't use the sign convention, minus. So G into here we can take as, so mass will be 1 kg and this will be a 4 kg. Sorry, this is an 8 kg will be getting, by here will be getting as this distance of separation will be 4 will be getting 4 square. So when you are taking common here, this is 4 by 4, here it will get cancelled, and here this is 8 by 4, 4 that 16 will be getting. So here 8 one times and here 8 two times it's going. So here we will be getting a G minus G by 2 will be getting. So the answer value will be getting as net gravitational force will be G by 2 will be getting. So this is the correct answer. Let us see the next question. The mass of a ball is 4 times that of the mass of the another ball is given. So mass of the ball is m1 is given as 4 times that of the mass of the another ball is given. When these balls are separated by distance 10 centimeter, or else you can take here if m1 you are taking as m you are taking, m2 here it becomes the mass of the ball is 4 times that of the mass of the another ball. 4 times of the mass you can take. Now here these two are separated by distance 10 centimeter. The gravitation force of attraction between these two will be 6.67 into 10 power minus 7 newtons. Then the masses of each ball they are asking. Now here you just calculate force of attraction between these two masses will be F equals G m1 m2 by, you can take as r square you can take. And here it's given as the force between them also it's given as 6.67 into 10 power minus 7 newtons is given, and G value 6.67 into 10 power minus 11. Masses is given as m into 4m you can take m1 m2 by r square. Distance of separation you can take as 10 centimeter you have to convert this whole square. So 6.67 gets cancelled, and here it will be 10 power minus 7. Now here it becomes 10 power minus 4. So when you are bringing this side, here it becomes 10 into 10 power minus 1. So 10 power minus 1 whole square means 10 power minus 2. Just bring this side. It will be equal to 10 power minus 4 into, you can take as 4m square you can take this product value. So when you are simplifying this one, here you will be getting as 10 power minus 2. Then here you will be getting as 4m square, which will be equal to, it's a 1 by 10 power minus 2. And here when it comes to the numerator, it becomes 100. And 25 times it is going, then here m square equal to 25 means here m value will be getting as 5 kg you are getting. So here 1 kg, one value will be m equal to 5 kg, and second will be 5 into 4, 20 kg you will be getting. So mass m1 equal to, here we will be getting as, this is 5 kg, and here m2 value will be getting as 4 into 5, in the sense here you are getting as 20 kg. So 5 and 20 kg is the correct answer. Let us take the next question. The next question says the two particles of masses 2 kg and 3 kg are at the points 1, 2 meter and 4, 6 meters is given. Position vectors of the two particles is given. Then the gravitation force on 3 kg particle due to the 2 kg particle. So we need to calculate the force on this 3rd kg particle. This will be attracted by 2nd kg mass along this direction. Now just calculate here, these two are the position vectors. First you need to calculate the distance of separation between these two. So here initial position vector r1 is given as I cap plus, here you can take as this is 2j cap you can take, and r2 bar it's given as second particle is going to be located at, so it's a 4i cap plus 6j cap you can take. Then here you can take as displacement vector, in the sense r bar equals, you can take as r2 bar minus r1 bar, which is nothing but you can get it as 4 minus 1 into I cap plus, here we will be getting a 6 minus 2 into j cap you can take. So this is nothing but here we will be getting as 3 I cap plus, here we will be getting as 4 j cap we will be getting. The magnitude of this r value, in the sense here you can take as sum of, this is 3 square plus, here you can take as 4 square, which is nothing but we will be getting as 5 meter distance you will be getting. So distance of separation between these two will be, it's a 5 meter we are calculated. Now here a force acting on the 3rd kg particle by the 2 kg particle, in the sense here F equals, you can take as G into, it's an m1 m2 by, here you can take as r square you can take. So this is 6.67 into 10 power minus 11 into mass m1 is given as 2 kg, and here the next mass is given as 3 kg by r square, in the sense we got it as 5 square 25. So now here you have to simplify this value. Here 2 into 3 will be getting a 6. So 6 is 36 this value. F32 value will be getting as nearly, it's a 1.6 into 10 power minus 11 newtons will be getting. When you are simplifying this value, you are getting the result like this. So we just look at the next question, students. Here find the net force acting on 2 kg due to the 3 kg and 4 kg they are asking. So here distance of separation is given as, here 3 meters is given between these two, 3 meters distance, and between these two is given as 2 meter distance is given. Now here you just calculate this mass, here it will be attracted by this mass along this direction, 2 kg mass, and 2 kg mass again it will be attracted by this 4 kg mass along this direction. Let us give the name as, this one will be F1 you can take, and here you can give the name as F2. Between 2 kg mass and 4 kg mass, distance will be less will be getting, then force value will be more will be getting. So here the net force when you are talking, here you can take as, this is F2 minus F1 you can take. F2 when you are talking distance, here you can take as, this is G into you can take as 2 kg into 4 kg by distance of separation will be 2 square minus F1 in the sense, here you can take as G into, here it is 2 into 3 by, here you can take as 3 square you can take. So when you are simplifying this one, here you can take this is 2 square 4 and 4 gets cancelled, and here it will be this is 3 square and 3 gets cancelled. Here you will be getting as, this is 2g minus, here you can take as 2g by 3 you can get, 3 2 is 6 minus 2 will be getting as 4, 4 by 3 you will be getting. So this is an F net value, here 4 by 3 into G value 6.67 into 10 power minus 11 Newton meter square per kg square you are getting. So 4 into 6.67 by 3 in the sense, here when you are simplifying this value, net force will be getting as nearly 1.6 into 10 power, this is this is nearly will be getting as it's an 8.9 into, here will be getting as 10 power minus 11 newtons will be getting. 8.9 into 10 power minus 11 newton is the correct answer. So let us see the next question, student. The centripetal force acting on the satellite orbiting around Earth and the gravitational force of the Earth acting on the satellites both will be equal to F. The net force on the satellite they are asking. So here a satellite is going to be orbiting around Earth is given. Here this is Earth you can take, and here one satellite is going to be revolving around Earth. And the gravitational force acting on the satellite on the Earth and the satellite will be equal to F is given. The net force acting on it. So net force in the sense, here you will be getting as net force is going to be providing the centripetal force. So here you can take gravitational force provides centripetal force when it's moving in a circular path. So F net is nothing but, here what you can say, that's nothing but, so gravitational force of Earth acting on the satellite will be both equal to F is given. So here the net force also will be getting as F only will be getting. This is the correct answer. Let us see the next question. Find the gravitational force acting on the mass M they are asking. So here the mass is given as M is given. Now here you just calculate, and these two are lying, one is lying on x axis and another is lying on the y axis is given. So F net force in the sense, here you can take, so now here you can take this mass will be attracted by this one along this direction, and this mass will be attracted by this one along this direction. Let us take it as F1 and F2. Let us take F1 which will be equal to, here you can take it as G into, so here this is small m into, here you can get it as 64m by, here you can get it as 88064d you will be getting, and F2 value you can get it as G into, the force of attraction between these two is here G into small m into, so here it is 36m by distance of separation will be getting as 60 whole square, 6 6 36 into d square you are getting. Now when you are simplifying this one here, the net force in the sense resultant of these two, one is lying on x-axis and one more is lying on y-axis. The resultant of these two forces acts along the diagonal. F net, which will be equal to, here you can write as F1 square plus F2 square plus 2F1 F2 into cos 90 will be getting. So cos 90 value will be 0, this whole thing will be 0 will be getting. Now when you are simplifying this one, so here this 64 and 64 gets cancelled, and here 36 gets cancelled. So the remaining values will be getting a G small m into capital M by D. This is D square, you are getting D square plus the next thing is here will be getting a G small m into capital M by, here will be getting as D square, you are getting. So this is nothing but 2 times we will be getting when so here you can write it as root 2 into, here you can get it as G small m into capital M by D square will be getting. So root 2 into G capital M into small m by D square. Second one is the third one is the correct answer. Well, this one you can write it as 2 times of here G small m into capital M by D square, you are getting, it will be under root. So here for this one here it will be square root and root gets cancelled. So here we will be getting as root 2 into, here we will be getting as GMM by F1 square, it's given. Sorry students, here it will be square, this is square and this will be also square, will be getting. Now square and root gets cancelled, here we will be getting as root 2 into, here this is square will be getting. So this is the correct answer. Let us see the next question. Two metal spheres of same material and radius are in contact with each other. The gravitational force of attraction between the spheres is proportional to. So here it's given as two metal spheres is given. So here it's a radius is given as small r it's given, and here they are in contact is given. R is the radius you can take. The gravitational force of attraction between the spheres is proportional to. So here material is same, means density value you can take as same you can take. It's nothing but F equals to, here you can take as G, it's an M1 M2 by, this is a basic formula you can take as R square. Let us take this is M1 and M2. Mass in terms of the volume and density in the sense, here you can write it as F equals to G into, the first one we will be getting as 4/3 pi R cube into rho will be getting, and here the next case also here will be getting as 4/3 pi R cube into rho will be getting by, here you can get it as R square in the sense, here the distance of separation between these will be getting as 2R will be getting. So 2R whole square means here you can get it as 4R square you are getting. And when you are relating R value, here F is directly proportional to numerator R power 6 will be there, and denominator R power 2 will be there, and here it will be 4 times. Then here we will be getting as F is directly proportional to R power 4 will be getting. F is directly proportional to R power 4. Let us see the next question, students. The next question says here 2 point masses A and B having masses are in the ratio 4:3 is given. It's represented by a distance as 1 meter. It is separated by distance is given as 1 meter it's given. Now here when another point mass C of the mass capital M is placed in between A and B, the force between A and C is 1/3 of the force between B and C. Then the distance of C from A they are asking. Here it is given as 2 point masses A and B. So here you will be getting as one mass you can take as A and B, they are in the ratio. So mass of the A you can take, students, here it becomes 4m, and mass of the B you can get it as 3m you can take. These two are separated by distance is given as 1 meter it's given. So their separation distance is given as 1 meter, it is given. When another point mass C of mass capital M is placed in between A and B is given, and here this is M you are going to be taking, and in between these two, here you can write as this is 1 by 2 meter and this is 1 by 2 meter distance you are placing. The force between A and C is 1/3 of the force between A and C is 1/3 of force between B and C is given. Then the distance of C from A they are asking. So it is not at 1 meter, students. Here you can write as at R distance you are placing. So here you can write that this is at R meter distance here you are placing. The obviously here will be getting as 1 minus R distance you can take. So this is the condition is given. Force of attraction between A and C which will be equal to 1/3 of force between the B and C will be getting. FAC when you are talking between this is A you can take and this is B you can take and this is the C mass you can take. FAC in the sense here will be getting as G into this is 4m into mass will be m by here you can get as distance r square you can take, which will be equal to 1 by 3 into G into force between these two will be this is 3m into capital M by here you can take as 1 minus r whole square you are getting. Now when you are simplifying this one, this side GG gets cancelled and small m capital M, and this side small m capital M gets cancelled, and here we will be getting as this side here will be getting as 4 by r square left side, which will be equal to here we will be getting as this side 3 and 3 gets cancelled, here we can get it as 1 minus 1 by r whole square. So when you are simplifying this one, 1 minus r by r whole square which will be equal to you can get as 1 by 4, and 1 minus r by r which will be equal to 1 by 2 you can take. When you are simplifying this one, here you can get it as 1 by r minus 1 you will be getting, which will be equal to 1 by 2. So when you are simplifying this one, 1 by r which will be equal to 1 by 2 plus 1 will be 3 by 2. Then here r value when you are taking this one, here it becomes 2 by 3 meters you will be getting. So r equals to 2 by 3 meter is the correct answer. Let us see the next question, students. A large number of identical point masses here m are placed along the x-axis at x equal to 0, 1, 2, 3, 4 and so on, it's given. And here the magnitude of the gravitational force and mass m at the origin x equal to 0 will be there asking. Right here it's given as right the magnitude of gravitational force on mass m which is kept at the origin they are asking. Here it is given as this is here one mass you are keeping at the origin, and here you are keeping at mass m, and here it will be mass m, and here it will be mass m, and here you will be getting and so on it's given. And here from the origin it is at 1 meter distance, and from the origin it is at 2 meter distance, from the origin it is at 4 meter distance, like and so on it's given. Now here the gravitational force which is kept on the origin they are asking. So here you will be getting as this mass can be attracted by second mass, here it will be along this direction. Let us take this is F1, and here this mass again here this mass will be attracted by this one along this direction will be getting, and again here the origin mass will be attracted by this one along this direction will be getting F3. So here and this mass also will be attracted by this one along this direction will be getting. Now here let us calculate the resultant force of these all. So here we will be getting as F equals to, here you can get it as net resultant force will be F1 plus F2 plus F3 plus and so on will be getting. F equals, here you can get as G into M you will be getting as M square by R square, in the sense 1 square will be getting, plus G into M square by, here will be getting as 2 square, plus G into M square by, here will be getting as 4 square will be getting, like and so on you can take, students. So here F, when you are taking, here it is Gm square into, here you can take as 1 plus, here it becomes 1 by 4 plus 1 by 64, sorry 1 by 16, like 1 by 64 plus and so on, like that we will be getting. If ratios of the second term to the first one and the third term to the second one and fourth to the third one, if the ratio will be same, in the sense here it will be under GP. In geometric progression, here in geometric progression, for infinite series, here S infinity equals, here you can write as A by 1 minus R. A is nothing but here whichever the first term will be there, that you can take. R in the sense ratios you can take. Ratio of the second to the 1 or third to the 1, that will be constant, you will be getting as R by R equal to 1 by 4. So then F value here you can get it as Gm square into, here will be getting as, so here A in the sense 1 by 1 minus 1 by 4 you can get, which is nothing but here will be getting as, when you are simplifying this one, you will be getting, and this value will be 4 by 3 into, here you can get it as Gm square, you will be getting 4 by 3 into Gm square is the correct answer. So next, let us see the next question, students. Here a physical balance is given and here it is balanced by 10 kg mass. If 1000 kg mass is placed at 1 meter below the one pan of the balance, here it's given as one simple balance is given, and here so here it's going to be balancing here by 10 kg mass. Now here you are placing a 1000 kg mass, you are going to be placing here at a distance of here 1 meter distance you are placing below one pan. How much mass is placed on the other pan? So here how much mass here you are going to be placing on the other pan, so that the physical balance again to be balanced. Furtherly it is going to be balancing. Now you can take, students, here there is a force of attraction before adding this mass. Here you will be getting as F equals to, here you can take as G into small m into capital M by R square you can take. Here you can take as, this is 6.67, between these two you can take. Initially you are placing, this is a 10 kg mass you can take. 6.67 into 10 power minus 11 into, here you can take as, this is 1000 kg into 10 kg by, here you can get it as R square. Distance will be 1 square you can take. Now here it's going to be balanced by, furtherly it's going to be balanced by one more mass they're asking. So here when you are simplifying this one, this is 10 power 3 and here at 10 power 4 and here it becomes 10 power minus 7 will be getting. And this value is 6.67 into 10 power minus 7, and F equals, here you can take as M into G value. G I am just taking as 10. So when you are simplifying this one, here you can get it as, so mass value will be getting as 6.67 into 10 power minus 7 by 10, which will be equal to 6.67 into 10 power minus 8 kg you are getting. This is the mass which you are going to be placing furtherly, then it can be balanced again. So here all the options is given as Newton is given. This is, you have to change it as kilograms. Now here let us see the next question, students. Here the force between two objects of, here it is given as equal masses is given as F is given. If 25% of the mass of one object is transferred to the other object, the new force will be there asking. So here you can take F equals to, here you can take as initially force between the two equal masses is given, G into M1 M2, both will be same. So here you can take as, this is m1 you can take as m, you can take m2 also it is given as m by here you can take as r square you can take. Now here 25% of the mass it is transferred to the another mass. Initially these two are separated by distance r you can take. So 25% if it is transferred to the second mass, in the sense here the remaining mass will be here m minus m by 4, which will be getting as 3 by 4 m will be left over. And here m by 4 mass it is transferred, in the sense here m plus m by 4 will be getting as 5 by 4 m will be getting. This is a new mass will be getting, and these two are separated by distance r you can take. Now here f dash which will be equal to g into m1 m2. So here now the new mass will be 3 by 4th of the m into here you can take as 5 by 4th of the m by the separation distance is not given any changes. So here you can take this is 3 5s will be getting as 15, 15 by 4 4s will be getting as 16 will be getting into you can take as g into, so here m into m by here you can take as r square you can take, which is nothing but f dash equals to this is the initial force value, this is 15 by 16 times of the f we are getting. So it's a 15 by 16 of the f is the correct answer. Let us see the next question, students. If the mass of one particle is increases by 50% and the mass of the another particle is decreased by 50%, the force between them they are asking. So here initial force we can take, here these are two particles, here it is given m1 m2 and these two are separated by distance we can take some r distance we can take, and the force of attraction between these two masses will be F equal to g m1 m2 by you can take as r square you can get. Now here one particle mass is increases by 50% is given. Right, here you can take as one particle mass, here it is increases f dash which will be equal to, now here g into, here a mass of one particle is increased by 50%. Here the first particle mass you are increasing like m1 plus 50% of m1. It's nothing but here will be getting as 50 by 2, here 2 times, here will be getting as 1 plus 1 by 2 will be getting as 3 by 2 of m will be getting. So here we will be getting as this is 3 by 2 of m1, and second thing is mass of another particle decreases by 50%. m2 now it is going to be decreasing, m2 minus here it is 50% you are going to be decreasing. Then here this is here 1 by 2 times, here m2 by 2 will be getting. So here you can get it as this is m2 by 2 you can take by separation distance, here they are not talking, you just keep like the same thing. So here we will be getting as 3 by, here we will be getting as 4 will be getting into, here we will be getting as g into m1 m2 by this is here we will be getting as r square will be getting. Suppose the initial value if it is 100% in the sense, here 3 by 4 into 100, 425%, so here we will be getting as 75% will be getting. So here the answer will be getting is okay, it's given as 7 or else 75% of f here, which will be equal to so here it is by 2, here the force between them they are asking. Here we can take this is the question here. So they're asking here delta f value, they're asking delta f, which will be equal to, here you can take as f dash minus f you can take, which will be equivalent to here f dash is nothing but here we'll be getting as, this is 3/4 of f will be getting, minus here initial force will be f you can take here, which is nothing but this is minus 1/4 will be getting. So here we'll be getting as, it's a decreases by 25% of the force will be getting, decreases by 25%. So let us see the next question, students. Here the distance of center of the moon and earth is given as d is given, and here the mass of the earth is 81 times that of the mass of the moon is given. So here the mass of the earth is given as, here this is the mass of the earth is given as 81 times that of the mass of the moon it's given, and here you can take this is the mass of the moon, and these were separated by distance. Here it is given as some d is given. So at what distance from the center of the earth the gravitational force on the particle of mass m0 will be equivalent to 0. So here you can take, let us take an assumption here somewhere the particle will be, you are keeping in the sense the mass m0 when you are keeping, so it will not experience any gravitational force. Let us take this value will be some x distance you can take, and here this value will be d minus x distance will be getting. Then here this mass will be attracted by this one along this direction, and this will be attracted by this one along this direction will be getting. So net force, if it is 0, they are asking F1 plus F2 equal to 0, then you just equate to only its magnitude, F1 equal to F2, which is nothing but we will be getting a G into. So here between these two, in the sense here we will be getting as, it's an 81 m into, here we will be getting as m0 by, here you can take it as x square, which will be equal to, so G into, here you can get it as capital M into, this is m0 you can take, by here you can take it as d minus x whole square you can take. So G gets cancelled, capital M you just cancel, here m0 gets cancelled, this is d minus x, you just cross multiply this one whole square, which will be equivalent to, so here we will be getting as 1 by 81, so it's a d minus x by x, which will be equal to 1 by 9 we will be getting. So when you are simplifying this one, d by x minus 1, which will be equal to 1 by 9. So when you are simplifying this one, d by x, which will be equal to 1 plus 1 by 9, which is nothing but we will be getting as 10 by 9 we will be getting. Then here you will be getting as x equal to, you will be getting as 9 by 10 of the d you will be getting. 9 by 10 of the d is the correct answer. Let us see the next question, student. The net force on any one of the particle they are asking. Here it's given as an equilateral triangle, it's given. All the sides is given as same is given, and here you are keeping on mass m, and here also on mass m you are keeping, and here this side you can take as a you can take. So the mass of any particle in this sense, here let us give the names as a, b, c. Let us calculate here at this point. So this mass here you need to concentrate. This mass will be attracted by c mass by the b particle towards b. So FCB, it will act along this direction, and again c particle will be attracted by a particle along this direction will be getting. Then force acting on the c by a will be getting like this. Both the magnitudes will be same. FCB, which will be equal to FCA you can get, which is nothing but g into, this is here m into m square by a square you are getting. If the two forces are acting, it's making an angle 60 degrees in the sense, resultant of these two forces of equal magnitude, F net equals will be getting as root 3 times of the F will be getting, which is nothing but root 3 into, here you can take it as gm square by, you can take it as a square you can take, gm square by a square. This is the correct answer. Let us see the next question. 3 equal masses is given as m are placed at the 3 corners of an equilateral triangle of side A. So here it is given as an equilateral triangle, it's given. And here all are equal masses is given. Our side is given as A is given. Find the force exerted by this system on the another particle of mass m placed at the midpoint of his side. So let us take here one particle. If I am keeping here, right, this is the first case we can take. You are keeping at the midpoint of a side is you are getting. So here when you are talking here, you can take, and here this mass will be, this distance will be getting as a by 2, and this distance will be a by 2 will be getting, and the force of interaction between A, B, C, you just give the name, and this is the D particle, you just give the name. So D particle will be attracted by B particle along this direction, FDB will be getting along this direction, D particle will be attracted by C particle along this direction, FDC will be getting. So here you can take FDB, which will be equal to FDC, which will be equal to G into M square by distance of separation will be getting as A by 2 whole square, which is nothing but will be getting as GM square, 4GM square by A square you are getting. But both the forces, they will be having equal magnitude, but they are in equal in opposite direction. These two gets cancel each other. Only one particle will be left over, and that is an A particle. So D particle can be attracted by A particle along this direction. This is here you can take as FDA you can take. Then FDA is nothing but here you can take as G into M will be M square by. So here this distance here will be getting as root 3 A by 2 will be getting. So here you can take as root 3 A by 2 whole square you can take, which will be equal to, so GM square by A square into 2 2s are 4, 4 by 3 will be getting. So 4 by 3 into GM square by A square you are getting. This is the first one answer. Let us see the next scenario. Here you will be given as, so here and it's an equilateral triangle, it's given. It's an equilateral triangle, it's given. And here now you are keeping the another mass m at the center of the particle. This is here you can take as small m you can take, and here this is m you can take, and this is m you can take, and here you are keeping the center at m. So here distance from any vertex will be getting as, here if the sides is given as A is given means here you can take this is A by root 3, and here to here also will be getting as A by root 3, and here to here also will be getting as A by root 3 will be getting. Now here let us see the scenario. Here this mass will be, let us give the name A, B, C you can take, and this is the O is the centroid particle mass you can take. Then O particle will be influenced by B particle along this direction. So FOB it will act along this direction. In the same way, O particle can be attracted by C particle along this direction. FOC will be getting. FOB which will be equal to FOC will be getting, which is nothing but G into M square by, so this is A by root 3 whole square you are getting. That's nothing but here you can take as G into M square by A square you will be getting. So now these two forces, they are making an angle 120 degrees. If equal magnitude is given, if the forces will be having equal magnitude and they are making an angle 120 degrees, in the sense F net force which will be equal to F will be getting. Now here the net force of these two resultant FOB and FOC to act downward direction. This is the F net. F net equals F will be getting, that is also nothing but here we will be getting a G3M square by A square you are getting. One more particle will be present, A particle, then force acting on the O particle by the A particle also here will be getting as G into M is M square by, here will be getting as A by root 3 whole square. So here between these two you can take again. Now this will be attracted by this one, A particle along this direction. Now here also will be getting as 3GM square by A square you are getting. Now these two forces, they are going to be acting equal in magnitude but is in opposite direction. Net force value will be getting as, F net value will be getting as 0 will be getting. So one answer will be 4 by 3 GM square by A square, and another one will be 0 you are getting. Let us see the next question, students. Here the next question says, here are two particles each of mass m are placed at the point P and Q are such that PO, which will be equal to, here it's given as OQ is given, which will be equivalent to L. The gravitational force on the third particle M placed at R, where OR is given as L is given. Now here we need to calculate the gravitational force on the third particle, which is keeping at the equatorial line. Here it's given as mass m is given, and here it's mass m is given, and here this is the point P and Q is given, and here you can take as O is the point, and this is an R point you can take, and this is L is given, and L is given, L is given. Now here PO equal to OQ equal to L is given. PO, which will be equal to OQ, which will be equal to L is given. The gravitational force on the third particle M, you are going to be placing capital M. So at a distance R, at a point R, where OR equal to L is given. So now look at, students, here this is L is given, and here this mass can be attracted by this mass along this direction. Means here FRP you will be getting along this direction, and again this mass will be attracted by Q mass will be along this direction. FRQ will be getting along this direction. Now here you can take, here it is given as L is given, and here it is given as, here it is L, and here it will be L. The hypotenuse will be getting as L square plus L square, and you will be getting as root 2 L will be getting, and here also will be getting as root L is the distance. Then here this is, here this is a 90 degrees in the sense, here all the both the sides will be equal. This is 45 degrees in the sense, and here force between these two vectors also will be getting as 90 degrees will be getting, and this is also 45 degrees will be getting, because two sides will be same. And here the net resultant force F net equals, here you can take as FRP square plus, here you can take as FRQ square plus 2 into FRP into you will be getting as FRQ into you will be getting as cos 90 will be getting. So cos 90 value will be 0, and here you have to cancel this one, and now here we will be getting as, this is, here both the magnitudes will be same, then here we will be getting as root 2 into, here you can take as FRP, or else here you can take as root 2 into FRQ you can take. So force of attraction between these two masses in the sense, here we will be getting as root 2 into G into, so one is capital M into small m by, here we will be getting as distance of separation in the sense, here we will be getting as root 2L whole square. So here which is nothing but, here we will be getting as root 2 into G into capital M into small m by, here you can take as 2L square you can take, and here we will be getting G capital M into small m by, here we can write denominator 2 as root 2 into root 2, then here we will be getting as root 2L square we will be getting. So here R2, so resultant of these two forces, here it will be acting along this direction. So here it is RO. Second one is the correct answer. Now let us see the next question, students. Here it's given as a 3 kg mass and 4 kg mass are placed on x and y axis at a distance of 1 meter from the origin, and a 1 kg mass is placed at the origin, it's given. Then the resultant of gravitational force on 1 kg mass they are given. And here it is given as, it's a 3 kg and a 4 kg mass you are placing. This is 3 kg mass, and here it will be a 4 kg mass you are placing, and along x and y axis at a distance, here it is given as 1 meter distance from the origin. So the resultant gravitational force on 1 kg mass which is kept at the origin, it's given. So here at the origin you are giving 1 kg mass. Now here let us see the students, here this mass can be attracted by this one along this direction F13, and this mass will be attracted by this one along this direction F14. Resultant of these two, it will be acting along this direction. Whereas F13 magnitude, when you are talking, G into mass M1 will be 1 kg and this is 3 kg by, here you can get as distance of separation will be 1 square. So you'll be getting as 3G. Whereas force experienced by the 1 kg mass by the 4 kg mass, in the sense F14 you can take G into, you can write it as 1 into 4 by, here you can take as 1 square is the distance. So here we'll be getting as 4G. And these two forces, they are making an angle 90 degrees. Then F resultant, in the sense here you can get it as F1 square plus F13 whole square plus F14 whole square plus 2 into F13 into F14 into cos 90 will be getting. Cos 90 value will be 0, F net which will be equal to, here you can get it as 3G whole square plus here you can get it as 4G whole square you are getting. So here we will be getting a, this is summation will be getting as 5G will be getting. So 5G is the correct answer. Let us see the next question, students. Here are 3 uniform spheres, each having a mass m is given and a radius is given as capital R, is kept in such a way that each two touches the other, it's given. The magnitude of the gravitational force on any one of the sphere due to the other two they are asking. So here are 3 spheres you are going to be keeping like this. Now here each one is touching the other, it's given. Of each mass is given and its radius is given. Now here there is a force of attraction between these two masses. Here when you are talking, this is a radius is given as R, and here it's going to be forming like an equilateral triangle. So the distance of separation between these two will be getting as 2R will be getting, and here also will be getting as 2R will be getting. Now here if you are taking the force of attraction on any sphere due to the other two, in the sense here this sphere, let us give the name as A, B, C is the sphere. C can be attracted by A along this direction, FCA will be getting. FCB, C will be attracted by B along this direction, will be getting FCB. So FCA magnitude and FCB magnitude both will be same, that's nothing but G into, so all the masses will be same, GM square by, here will be getting as 2R whole square is the distance of separation. So you can write it as GM square by, you can take it as 4R square you can take. Now here these two forces, they are making an angle here 60 degrees will be getting, well because here it's forming like an equilateral triangle 60 degrees. Then F net, in the sense here if equal magnitudes when you are taking, here it becomes root 3F. Root 3 into F, in the sense here you can take it as GM square by, here will be getting as 4R square you are getting. Root 3 into GM square by 4R square is the correct answer. Let us see the next question, students. Here are 3 spherical balls of masses 1 kg, 2 kg and 3 kg are placed at the corners of an equilateral triangle. Of side is given as 1 meter. The magnitude of the gravitational force exerted by 2 kg mass on the 3 kg mass is on 1 kg mass they are asking. So here it's given as an equilateral triangle, it's given. And here it is given as 1 kg mass is given, and here it is given as 2 kg mass, and here it is given as 3 kg mass it's given. Of side is given as 1 meter it's given. The magnitude of the gravitational force exerted by this 2 kg mass and 3 kg mass on 1 kg mass they are asking. Now here you just look at, students, here 1 kg mass can be attracted by 2 kg mass along this direction. That's a force acting on 1 kg by the 2 kg. And here this value will be F12, which will be equal to G into 1 kg into, this is 2 kg by distance of separation will be 1 square. So here we will be getting as 2G will be getting. Now here 1 kg mass can be attracted by 3 kg mass along this direction. This is F13, you can give the name. It's nothing but F13, which will be equal to G into 1 into 3 by, here we will be getting as 1 square you are getting. It's nothing but here you can take as 3G you can take. Now here it's an equilateral triangle is given, angle between these two vectors will be 60 degrees. The resultant of these two, it will be acting along this direction. then F net is nothing but, here you can write as F12 square plus, here you can write it as F13 square plus 2 into F12 into F13 into, will be getting as cos 60 degrees will be getting. So here 2g whole square in the sense, here you can write as 4g square you can take, and 3g whole square in the sense, here you can write as 9g square into 2 into, this is 2g into 3g into, here you can get it as 1 by 2. So this 2 gets cancelled, here you can write as 4 plus 9, you will be getting as 13g square. So 13 plus 2 3s are 6 will be getting, so here we will be getting as root over 19g will be getting. So root 19g is the correct answer. Let us see the next question, students. Here the net force on any one of the particle they are asking. So here it is given as a square form, it's given. So this is here m you can take, and this is m you can take, and here it is m, and here it is given as m. All the sides is given as same, it's given. We just give the names for this one as, here you can give A, B, and here you can get it as C, D, like that you just give. They're asking net force on any one of the particle they're asking. Now here D particle, you need to consider. D particle will be influenced by A particle, B particle and C particle. D particle will be attracted by C particle along this direction, this is FDC, and D particle will be attracted by B particle along this direction, FDB will be getting. Both the magnitudes will be same, FDC equal to FDB, which will be equal to, you can write it as G into M will be M square by, here will be getting as A square. Then here these two, they will be acting perpendicular direction, resultant of these two will be getting as along this direction. So F resultant here will be getting as root 3 F will be getting, which is nothing but F, you just give the consideration root 3 into, here you can write as GM square by A square you are getting. So one more particle will be there, A particle. A particle is attracting the D particle, here it will be along this direction. Then here it is F DA also it will be getting along this direction, but the distance of separation here will be getting as from A and D will be here to here will be getting as root 2A will be getting. Then FAD, which will be equal to, here you can get it as G M into M is M square by root 2A whole square will be getting, which is nothing but you can get as GM square by 2A square you can get. So which is nothing but here root 3F you can take. This is 90 degrees, so this is here root 2F, this is root 2F, and this is root 2F. Here this one you can write it as F by 2 you can take. Now here F resultant, F net force, when you are talking here resultant force and FAD force both will be acting along the same direction, then you have to sum up all these. So now here we will be getting as F resultant will be getting as FR equals, here will be getting as root 2F plus, here will be getting as F by 2 will be getting, which is nothing but root 2 plus 1 by 2 into F, in the sense here you can take as GM square by A square you can take. So the answer will be getting as 1 by 2 plus root 2, this is here GM square by A square is the correct answer. Let us see the next question, students. The next question says here, 4 identical particles, point masses, each equal to m are placed at the 4 corners of a square of side is given as A is given. So here a square is given. And each mass is given as capital M is given. Are placed at the 4 corners of a square of side is given as A is given. Calculate the force of attraction on another point mass M kept at the center. So here this is here one more particle you are keeping at the center. Now here this mass will be attracted by this mass along this direction. So here with a separation distance of A by root 2. But because here we will be getting, this is A by 2 and here it will be A by 2 will be getting, and here obviously hypotenuse will be A by root 2 will be getting. Then this mass will be attracted by this one along this direction will be getting. And here also magnitude of separation will be same and force of attraction also will be same will be getting. These two will get cancelled. Now here again this mass will be attracted by this one along this direction. This is also at a by root 2 distance will be getting, and here to here this mass also will be attracted by this one along this direction. This is at a by root 2 distance. Then here net force acting at the center in the sense here will be getting as all the forces will get cancel each other. The net force value will be getting as 0 will be getting. Now let us see the next question, students. The next question says 4 particles of masses m, 2m, 3m and as well as 4m are kept at the sequence at the corners of a square of side is given as A. Here these are all not identical masses, students. Here you are keeping here when mass is given as m is given, 2m is given, and here it is given as 3m it's given, and here it is given as 4m it's given, and side square is given as A is given. The magnitude of the gravitational force acting on a particle of mass m which is placed at the center. So one more particle you are keeping at the center. Now here you can take, students. So now this mass will be attracted by this one along this direction. So this is a force you can take as, here you can get it as F you can take. F equals, here will be getting as G into m square by, here will be getting as A by root 2 whole square. This is nothing but 2 gm square by A square you are getting. This is F1 value. And here you can take as, so like F1 you can give the name, F2 you can take as. So here this mass will be attracted by this one along this direction, and here this distance will be A by root 2, and here this is gm square, or this is 3 into 3m into m. These masses will be different. So g into m into 3m by, here we will be getting as A by root 2 whole square you are getting, which is nothing but here we will be getting as 3 into, this is 2 gm square by A square you are getting, which is nothing but 3 times of the initial force you will be getting. That means here we will be getting this force will be F in this sense, this side force will be 3F we will be getting. In the same way here when you are talking this side, it will be attracted by this one along this direction. And now this force will be getting as 2F force will be getting, and this side whatever the mass will be present, this side here it will be 4F will be getting. Now here resultant of these two, one force is going to be acting F, here it will be, and here one more force will be 3F. Resultant of these net will be getting as 2F. It will be acting along this direction. 2F it will act along this direction. And here one more force is given as, here this force is given as 2F is given, and here this force is given as 4F is given. Resultant of these two again here will be getting as, here both will be in opposite direction. And these two resultant also F net equals will be getting as 2F will be getting 2F. So here you will be getting this side 2F, and this side will be 2F will be getting F net resultant force, it is going to be acting along this direction, resultant of these two. So F net you can write it as so here you can write this is 2F and F, and here this is at the midpoint in the sense here will be getting as, here this side length will be same, and these two are making an angle 90 degrees will be getting. So now you can take here this is 2F whole square plus 2F whole square plus 2 into, you can take as 2F into cos 90 you can take, and this value will be 0. So 2F whole square means 4F square plus 4F square will be getting as, this is 8F square will be getting. So here we will be getting as 2 root 2F you can take, which is nothing but 2 root 2 into F is nothing but here the initial value you can take, which is nothing but this is G into m square by, this is A square you can take. this is a by root 2 whole square, which is nothing but 2 whole square in the sense here will be getting 4 root 2 into g into m square by here will be getting as a square here. So third one is the suitable answer. Let us see the next question, students. Two particles each of mass m moves in a circle of radius r under the action of their mutual gravitational attraction. The speed of each particle they are asking. So two particles is given, each of mass is given as m is given. They are moving in a circle of radius is given as r is given under the action of mutual gravitational force. Now here gravitational force of attraction between these two masses will be F equal to G into m square by here the distance of separation between these two masses will be 2r will be getting. So here you can take as 2r whole square, which is nothing but gm square by 4r square here getting. Now here since here you can take as gravitational force is providing the centripetal force, then here Fc, which is nothing but here you can take as mv square by r you can take, which will be equivalent to gm square by 4r you can take 4r square, 1 rr gets cancelled, 1 mm gets cancelled, which is nothing but v square equals to getting as gm by 4r you are getting. And speed of each particle in the sense here you can take as v equals to here you can take as gm by 4r you can take. So let us see the next question. Three particles each of mass is given as m are located at the three vertices of an equilateral triangle. So here you are keeping three particles, each of mass is given as m is given, and they are placed at the located at three vertices of an equilateral triangle. Of side is given as a is given. If the system is revolving in a uniform circle due to their mutual force of attraction and their angular velocity of each particle they are asking. Now the system is going to be moving in a circle. So here the system is going to be moving in a circle. Now here angular velocity of each particle they are asking. Now here you can take it's going to be moving with some angular velocity omega. Now first you need to calculate the force of attraction on any one of the side you can take, students. So this mass here let us give the name as A, B, C. Just give the name. C particle will be attracted by B particle and C particle will be attracted by A particle along this direction. This is FCB can give the name and FCA can give the name. So FCB which will be equal to FCA which will be equal to G into masses will be m and m. Here you can take as m square by distance of separation will be getting as a square you are getting. Now these two magnitudes will be same, but they are making an angle 60 degrees will be getting. Resultant of these two it will be acting along its diagonal. Then if two equal magnitudes will be having, they are making an angle 60 degrees means the resultant force will be getting as root 3f, which you can give the name as f. So it is root 3 into this is gm square by a square you are getting. But here net force is providing some centripetal force, which is nothing but here you can take as m into r into omega square you can get. Then when you are simplifying this one, m into r in the sense here radius you can take, here to here you will be getting as radius is nothing but here you will be getting as a by root 3 you are getting. Here it is a by root 3. So here we will be getting as a by root 3 into here you can take as omega square, which will be equal to root 3 into gm square by a square you can take. So one mass gets cancelled and here you can get it as omega square is nothing but, so here you just cross multiply this one, root 3 into root 3 will be getting as 3 into g capital small m by a square into a will be getting as a cube you are getting. Then omega value will be getting as here 3 into gm by here a cube under root will be getting. So this is an answer, right? 3 gm by a cube under root. Let us see the next question, students. Three identical point masses, each of mass is given as 1 kg, lies on xy plane at the points 0, 0 and 0, 0.2 meter and 0.2, 0. The net gravitational force on the mass at the origin they are asking. Three identical point masses is given and each of mass is given as 1 kg. Initially they are lying on the xy plane at the points. Here it's a 1 kg. Here you are going to placing at 0, 0. One more it is given as 0.0, 0.2. So 0, 0.2 in the sense here it's lying on y-axis. This is 1 kg mass. It's 0, 0.2 and the next 1 kg mass here it is going to be lying at. It's given as 0.2 meter, here it is 0 meter it's given. Now here the net gravitational force on the mass m at the origin they are asked. Now here you can take students. So this mass will be attracted by this one along this direction and this mass will be attracted by this mass along this direction. Now let us give the name as, like you can take as here this is A you can take, and here you can give the name as this is B particle and this is a C particle you can take. FAC it will act along this direction, FAB it will act along this direction. So here in terms of the position vector they are asking. So F net resultant force, which is nothing but here you can take it as FAC plus here you can get it as FAB bar you will be getting. FAC magnitude when you are talking the sense here G into M1 is mass will be 1 into 1 by here distance of separation will be 0.2 whole square you are getting here, which is along x-axis. So here Cartesian coordinate you can take as I cap you can take, and the next thing is here along y-axis G into 1 by here again you can get as 0.2 whole square you can take along J cap. Now here you just simplify this one students. Here you will be getting as G by here 0.2 whole square means 0.04 you can take. It's nothing but here you can take as I cap plus J cap you can take, which is nothing but 0.04 you can take as this is 6.67 into 10 power minus 11 into here we will be getting as this is 4 by 100, 100 by 4 in this is 25 you can take, into you can get it as I cap plus J cap you can take. So when you are simplifying this one here the answer you will be getting is here this is 1.67 into here this is 2560, here we will be getting as 1.67 into this is 10 power minus 11 into you will be getting as I cap plus J cap you will be getting. So this is the correct answer. 6.67 into 25, 6.67 into 25, 135. 175, 150 plus 17, 167, here 25, 6 150, 166, 2 decimals. 2 decimals in the sense here we will be getting as where this is 166.75, so here we will be getting as 167 into 10 power minus 11. So just bring this side, here we will be getting as 1.67 into 10 power minus 9. So this is 10 power minus 9 you are getting students. Here this is the third one is the correct answer. Let us see the next question. The next question says 2 point masses m and 4m are separated by distance is given as d on a line. A third point mass m0 is to be placed at a point on the line such that the net gravitational force on it is 0, it's given. So here it's given as one mass is given as here m is given, and here next one more mass is given as 4m it's given, and they are separated by distance d is given. on ln. A third point mass m is placed at a point on ln such that the net force on it is 0. So here it is given as this is m naught you are going to be placing, which is you are going to be placing at a distance x, and this distance here you can take as d minus x you can take. So here the net gravitational force value is 0. Here if you remember students, here distance force of attraction between these two will be getting as g into, so this mass will be attracted by this one along this direction, this mass will be attracted by this one along this direction. Then F1 plus F2 which will be equal to 0. Magnitude alone if you are talking F1 equal to F2 you can take, and F1 in the sense here you can take as g into m naught by here you can take as x square, which will be equal to g into small m into 4m m naught into 4m by here you can take as d minus x whole square you can take g small m, and here g small m gets cancelled, and here m naught gets cancelled. Then d minus x by x whole square which will be equal to, here we can get it as 4 will be getting, that's nothing but d minus x by x which will be equal to 2 you are getting. So when you are simplifying this one again, so take LCM, d minus x minus 1 which will be equal to 2, d by x which will be equal to 3 will be getting, then x equal to here will be getting as d by 3 you are getting. So d by 3 is the correct answer. Let us see the next question, students. The next question says 4 particles each of mass m are located at the 4 corners of a square of side A is given. If the system is revolving in a uniform circle due to their mutual gravitational force of attraction, then their angular velocity of each particle they are asking. So here this is one square it's given, and here all are identical masses, here m and m here it is given. Now the system is going to be revolving in a circle. Now here it's going to be rotating in a circle. Outside is given as A is given. So let us give the name as A, B, C, D. You just give the name like this. And here you can calculate the net force acting on any one of the particle. You just calculate, students. If I would like to calculate net force acting on the C particle, in the sense C particle will be attracted by D particle along this direction. C particle can be attracted by B particle along this direction. And here this separation distance will be getting as, here this is root 2a will be getting, and here we have seen in the previous questions F net resultant force will be getting as 1 by 2 plus root 2 into, here will be getting as gm square by a square you are getting. Now net force is providing some centripetal force. Centripetal force here we can take as mr omega square. So here angular velocity they are asking, r is nothing but here to here you can take, students. It's nothing but the radius. It's nothing but will be getting as a by root 2, and here to here the distance will be root 2a. Now here m into r in the sense here you can take as a by root 2 into here you can take as omega square which will be equivalent to 2. So root 2 plus here you can get it as 1 by 2 into here you can take as gm square by a square you can get. Here 1 mm gets cancelled. Now here omega square which will be equal to, here you can take 2 root 2 plus 1 by 2 into, you can get it as gm by a square into a will be getting as a cube will be getting, and here root 2 it will goes this side. Now here omega square which will be equal to, here you can take it as, this one I can write it as root 2 into, this is 2 root 2 plus 1 by, here you can take it as root 2 into root 2 into, you can take it as gm by a cube you can take, here root 2 gets cancelled. Then omega which will be equal to, you can take it as square root of, this is 2 root 2 plus 1 by root 2 into, here we will be getting as gm by a cube you are getting. So this is the correct answer. The next question says a uniform sphere of mass m is given and radius is given as r. It exerts a force F on a small mass m situated at a distance 2r from the center O of a sphere. It's given. Now a spherical portion of diameter r you are going to be removing from the sphere. The force of attraction between the remaining part of the sphere and the mass of the m will be there asking. Initially before removing you can take, students, here the force of attraction between the so this is the mass, it's given as capital M, and here it's given as small m is the mass, and initially these two are separated by distance is given as 2r, it's given. Now the force of attraction between these two masses will be G into capital M into small m by, here you can take as 2r whole square you can take. Now here a portion you are going to be removing, in the sense here, now here a spherical portion of diameter r you are removing. Diameter r in the sense here the radius value will be getting as, here it will be r by 2 will be getting. And here from 2r, here you are going to be removing r by 2 in the sense, now the distance of separation will be getting as, here I am just taking this mass you are going to be removing. So here removed mass in the sense, so here this is the removed mass you can take, students, this is a removed mass, here I am just giving. So removed mass diameter is given as r is given. Now here you can take it as the force of attraction, this is the m mass, and this is the removed mass you can take. Here the distance of separation between these two, which is nothing but here this is 2r will be getting. So here to here it will be 2r. So here to here it will be 2r will be getting, and here to here distance from its center to this point you have to take, here you have to take this is r by 2 is the radius. Now here distance of center of mass, distance between the two masses will be, now you will be getting as r dash, which will be equal to 2r minus, here you can take as r by 2 you can take. This is for 2 to the 4r minus r by 2, 4 or 3 by 2 r will be getting. So now here you will be getting as r dash equal to 3 by 2 r will be getting. Now here f dash you can take as g into, so here some portion mass you are removing, that mass you have to give the name as m dash you can take into m by, here you can take as 3 by 2 r whole square you can take. How much mass you are removing in the sense, here you can take as total mass by removed mass into, which will be equal to total volume. So here mass per unit volume in the sense, here this is 4/3 pi into r. Radius is nothing but here it's given as r is given, so here 4/3 pi r cube by, here you can take as 4/3 into pi into the removed portion radius will be r by 2 whole cube you can take. 4/3 pi gets cancelled, this is r cube, then which is nothing but here will be getting as m dash, which is nothing but here will be getting as, this is m dash, here it will be just cross multiply this one, m dash is nothing but here will be getting as m by 8 will be getting. Now removed mass will be getting as m by 8. Now here you can calculate the remaining force of attraction in the sense m dash equal to m by 8, here f remaining in the sense, here you can get it as f original mass minus here f removed mass, f force of attraction between the removed portion masses you have to take. So when you are simplifying this one, here will be getting as, this is g capital M into small m by, initial separation will be 2r by 2r whole square minus g into here m dash, it becomes m by 8 into will be getting as small m by, here will be getting as, this is 3 by 2 will be getting 3 by 2 whole square in the sense, here you can get it as 3 by 2 or whole square you can take. So when you are simplifying this one, f remaining in this is here f dash, which will be equal to f minus 2f by 9 you can get, which is nothing but here we will be getting a 7f by 9 will be getting. So 7f by 9 is the correct answer. Let us see the next question, students. Here the next question says which is related to the relation between small g and capital G is given. The radius and acceleration due to gravity of the moon it's given as 1 by 4 and 1 by 5 it's given of that of the earth. So radius of the moon it's given as, so here 1 by 4th of the radius of the earth. Radius of the acceleration due to gravity on the moon is given as, acceleration due to gravity on the moon is given as here 1 by 5 of the acceleration due to gravity on the earth is given. The ratio of the mass of the earth to the mass of the moon they are asking. The relation between small g and capital G will be G equal to Gm by R square you are getting. So here you can take the ratio of the mass of the earth to the mass of the moon. Now G is a constant value. Now here you can relate G, which is directly proportional to m by R square you can take. Now here m is directly proportional to, here you can take as G into R square. Here mass of the earth to the mass of the moon, which will be equal to G on earth to the G on moon into, here we will be getting as radius of earth whole square by, here you can take as radius of the moon square you can take. So GE by G on moon will be getting as 1 by 5th of the GE. So here we will be getting a GE by 5 into, here we will be getting as RE square. RE square by radius of the moon will be RE square by, here we will be getting as 5 5 is 25 will be getting. This is, sorry, this is 4 times 4 4 is 16 will be getting. So GE gets cancelled, RE gets cancelled. So here mass of the earth to the mass of the moon, which will be equal to, here the ratio will be getting as 1:2. This is here so 580. So here the ratio of the mass of the earth to the mass of the moon, G by G moon, and here we will be getting as RE square by RM square you are getting. So now here we will be getting as 5 into 16 we will be getting as 80. 80:1 is the correct answer. Now let us see the next question, students. Here a spherical planet far out in space. So here its mass is given as m0 and diameter is given as d0. It's given a particle of mass m falling freely. A particle of mass m is falling freely near the surface of this planet will experience an acceleration due to gravity, which is equal to, they're asking. So here a spherical planet is given in space. Now here a particle of mass m is going to be falling near to the surface. Now here a particle is going to be falling freely. Now here you know the relation between small g and capital G, students. G equal to Gm by R square you are getting. Now here R is nothing but the radius of the planet, m is nothing but the mass of the planet you will be getting. Now here a particle of mass m is going to be falling. Its diameter is given as d0, in the sense radius value will be getting as d0 by 2 will be getting. And here a particle of mass m is going to be falling like this on the surface of the earth. So now here a G, which will be equal to, here will be getting a G into m0 by, here radius, in the sense here you can take as d0 by 2 whole square, which is nothing but G equals to, here will be getting as 4 into gm0 by d square you are getting. This is the correct answer. Let us see the next question. A planet has a mass is given as 1 by 10th of the mass of that is given. while radius is given as 1/3 of that of the Earth. Say planet mass is given as, mass of the planet is given as here 1/10th of mass of the Earth is given, and radius of the planet is given as here 1/3 of the radius of the Earth is given. A man is jumping to a height 90 meter on the surface of the Earth. So height on the surface of the Earth is given as 90 meter. Then how much height he will jump, the same person on the planet. So how much height he will be raising. Now here h equals to here maximum height reached by the person, which will be equal to h equal to u square by 2g. Now just relate h equal to u square by g in the sense h is inversely proportional to g will be getting. Again g in the sense here you can take as gm by r square will be getting. Here mass and radius will be different. Here we can take as, which is nothing but gm by r square, then here r square by here will be getting as m will be getting. Now here you can take, students, the height which is he is jumping on the planet by height which he is jumping on the Earth, which will be equal to radius on the planet whole square by here radius on the Earth square you can take, into here you can get it as mass on the Earth by mass on the planet you can take, which is nothing but here radius on the planet in the sense, which is nothing but 1/3. So here it becomes re square by 9 you can take, into here will be getting as re square into mass on the Earth will be me by mass of the planet will be getting as here me by 10 will be getting. Here me gets cancelled, re square gets cancelled. H on the planet by height which is going to be jumping as 90, which will be equal to here you can take as 10 by 9. So 10 times here it is going. So here 10 into 10 here will be getting as height which is going to be jumping is 100 meters will be getting. So the next question says here the radius of the Earth is given as 6,400 kilometers and that of the Mars is given as 3,200 kilometers. The mass of the Earth is given as 10 times that of the mass of the Mars. Mass of the Earth is given as 10 times that of the mass of the Mars is given, and radius of the Earth is given as, this is 6,400 kilometer, and the radius of the Mars is given as 3,200 kilometers. So if an object weighs 200 newtons on the surface of the Earth, its weight on the surface of the Mars they are asking. Now you know the relation between small g and capital G, gm by r square you are getting. So here it's weight on the surface of the Mars. So here you can take as g on Mars by g on Earth, which is nothing but g is directly proportional to here you can take as m by r square you can take g on Mars by g on Earth, which will be equal to, so here mass on Mars by mass on Earth into here will be getting as re square by here you can take as rm square you can take. Mass on Moon in the sense here you just give the name. Here mass of that is 10 times that of the mass of the Mars into here we will be getting as re square by re square in the sense here we will be getting as 6,400 kilometer by rm in the sense here we will be getting as 3,200 kilometer whole square you can take. Here this is 2 times, here mm gets cancelled, here we will be getting as 1/10 into here we will be getting as, this is 2 square in the sense 4 you are getting. So now here you will be getting as just multiply and divide the m value with the m value when you are dividing, this is here m into g. So this is weight on the Mars by weight on the Earth will be getting. So here weight on the Mars which will be equal to 4/10 into weight on the Earth is given as here 200 it's given, here 10 gets cancelled, here we will be getting as it's a weight on the Mars which will be equal to 80 newtons you are getting. 80 Newton is the correct answer. Let us see the next question, students. Here if G and GP denotes the acceleration due to gravity on the surface of the Earth and the another planet whose mass and radius are twice that of the Earth is given. So here it is given as, then they are asking GP or GP-GE ratios they are asking. So you know the relation between small g and capital G, gm by r square you are getting. This is here we will be getting as g on earth by g on planet. G is of course is a constant value. Here you can take g is directly proportional to m by r square. You can get mass on the earth by mass of the planet into, here we will be getting as radius on the planet square by radius on the earth square you will be getting. So here you will be getting as mass and radius will be here mass on earth by mass of the planet is twice that of the mass of the earth. Radius of the planet will be 2 times of the radius of the earth. So here you can take as 4rp square by, you can take as re square by re square will be getting, rr gets cancelled, me gets cancelled. So ge by gp value will be getting as, here it is, so 2 times it is going, here will be getting as 2 will be getting. So here will be getting as ge which will be equal to, or else gp equal to, here will be getting as 1 by 2 of ge, which is nothing but 0.5 ge. So gp equal to, will be getting as 0.5 ge. Now let us see the next question, students. Here the acceleration due to gravity is g, and mean density is given as, here of earth are related by the which of the following relations. Here they are asking the acceleration due to gravity general formula will be getting as g equal to gm by r square. You are getting mass in terms of the density when you are writing g by r square into mass equal to volume into density 4/3 pi into r cube into volume into density. You can take here one r square and here one r gets cancelled. G equals to, you will be getting as 4/3 pi into r into rho into g you will be getting. Now they are asking here rho value, they are asking rho, you can write it as 3 into g by, here you can get it as 4 into pi into r into g you can take. So rho equal to 3g by, here you can take as 4 pi, this is here one rr gets cancelled, rho equal to 3g by 4 pi into g into r. This is the correct answer. Now the next question says here, if the radius of the earth is contracted by 0.5 percentage and mass remains same, the weight of the body on that surface will be increases by, you know the relation between small g and capital G, gm by r square you are getting. Radius of the earth is contracted, decreases by 0.5 percentage is given, and mass remains same. So here you just relate, here mass remains same and g is a constant value, you can relate g is inversely proportional to r square. Then here you can write as delta g by g into 100, which will be equal to, here you can write as, here it becomes r power minus 2. So minus 2 into, you can take as delta r by r you can take into 100 you can take. Here this delta r by r value is given as, here contracted means it's a decreased value is given as 0.5 percentage. It says a minus into minus plus 2 into 0.5 will be getting as 1 percentage. So 1 percentage is the correct answer. Let us see the next question. The mass of the earth is decreases by 25 percentage. And here the radius value is going to be increases by 50 percentage is going. The acceleration due to gravity at its surface decreases by nearly. So here this is a relationship you can take, student. G equal to gm by r square you are getting. Mass of the earth is decreases by 0.25 percentage is decreasing means m dash which will be equal to m minus 25 percentage of m you can take, here 25 4z, so here will be getting as 3m by 4. And the radius is increases by r dash value you can take, here initial radius you can take as some r you can take, plus here it is going to 50 percentage is increasing in the sense 50 by 100 you can take, here it is 1 by 2, so here we will be getting as 3 by 2 r will be getting. Now the new g dash value, so g dash which will be equal to, here g into m dash in the sense here we will be getting as 3m by 4 by, here we will be getting as r dash in the sense here we will be getting as 3 by 2 r whole square you can take. Now here when you are simplifying this one, g dash which will be equal to 3 by 4 into 2 by 3 you can take, into here we will be getting as gm by r square. So here 3 gets cancelled, 2 times, here it is. So 3 by 4 3 by 2, 3 by 4, 3 by 2, 2 by 3. This is square you need to talk, students, here, sorry. In denominator square function will be there. So in the numerator we will be getting as 3 by 4 into here we will be getting as 4 by 9 we will be getting. So here into gm by r square you are getting. So 4 gets cancelled 3 times. So here we will be getting as 1 by 3 of the g. So it's nothing but here we will be getting as nearly here g if you are taking as 100%, here we will be getting as nearly 100 by 3 in the sense nearly it's 67% will be getting. So it's going to decreases by 67% you are getting. Let us see the next case here. The acceleration due to gravity is given as at the surface of the planet is equal to that of the surface of the Earth, and the density is given as 1.5 times that of the Earth is given. If the radius of the Earth is given as r, and here the radius of the planet they are asking. So g in terms of the density in the sense here g equals to, you can take, students, here this is 4/3 pi into r into rho into g, you can take. This is the relation g in terms of the density. Now here r and rho when you are talking, here remaining all the values you can take as constant, means r into rho you can make it as constants. So here r is inversely proportional to rho, you can take. So radius on the planet to the radius on the Earth, which will be equal to density of the Earth by density of the planet, you can take. So here we will be getting as the radius of the planet they are asking. Radius on the Earth will be r, we just cross multiply density of the Earth by, here we will be getting as density of the planet is 1.5 times that of the density of the Earth is given. So here it will get cancelled, 1.5 in the sense here we will be getting as 3 by 2. Then radius on the planet will be, it becomes 2 by 3 times of the r will be getting. It's a 2r by 3. Let us see the next question. Here consider a planet in some solar system which has a mass double the mass of the Earth, and density is equal to the average density of the Earth is given. An object weighing W on the Earth, then its weight on the planet is. Now you can take, students, here you will be getting as, so here g equals to, here you can take as gm by r square you can take, which is nothing but here we will be getting as g is directly proportional to m by r square you can take. So here we will be getting as volume in the sense here volume which will be equal to 4/3 pi r cube will be getting. That means here r cube is directly proportional to v and r is directly proportional to v power 1 by 3 are getting. Volume in the sense here you can take as mass by density you can take. So here you just substitute this thing here in this equation. So here g is directly proportional to m by radius in the sense here you can take as volume. Volume again you can write as mass by density. So here you can take as mass by density whole power 2 by 3 you can take. So here which is nothing but m by, it's an m power 2 by 3 by, here we will be getting as, it's a rho power 2 by 3 you are getting. M by m power 2 by 3 in the sense here we will be getting as m power 1 minus 2 by 3 into, here we will be getting as rho power 2 by 3. So g is directly proportional to, here we will be getting as m power 1 by 3 into rho power 2 by 3 you are getting. So that means here you can take, now you can relate g on planet by g on Earth which will be equal to, so here you can get it as, so density is given as same is given, right? Average density is given as same is given. Now here you can take as here mass of the planet by here mass on the Earth whole power 1 by 3 you can get. So g on planet by g on Earth which will be equal to, here m you just multiply, here this is nothing but weight on the planet by weight on the Earth which will be equal to, here mp value will be getting as 2m is given already, here m whole power 1 by 3, gets cancelled, which is nothing but weight on the planet will be equivalent to weight into, So here we will be getting as 2 power 1 by 3. So this is the correct answer. Let us see the next question. Here acceleration due to gravity on the moon is given as 1 by 6 acceleration due to gravity on the moon is given as 1 by 6 of the acceleration due to gravity on the earth. If the ratio of the density of the earth and moon is given as, so 5:3 is given. The radius of the moon RM in terms of RE they are asking. You know the relation between G and G in terms of the density, the formula will be getting as G equals to, you can take as 4/3 pi into R into rho into, you can take as G. Now they are asking in terms of the density and right, G value and as well as radius. So G, which you can relate as R into rho, you can take. Now here you can take as G on earth by, so G on earth by here, or else you can take here itself radius we required. R is directly proportional to G by rho, you can take, which is nothing but radius of the radius on moon by radius on the earth, which will be equal to G on moon by, you can take as G on earth into, here you can take as density on the earth by density on the moon, you can take. So radius of the moon by radius on the earth, which will be equal to G on moon, which will be GE by 6, you are getting 6 times of GE into density of the earth by density of the moon is given as 5/3. GE gets cancelled. Here you will be getting as radius of the moon by radius of the earth, which will be equal to 5 by, this is 18. So here we will be getting as RM in terms of RE. So here we will be getting as RM value, RM which is nothing but 5/18 times of the radius of the earth. First one is the correct answer. Let us see the next question. The next question says two planets have the same average mass density, but their radius are in the ratio 1:2. The ratio of their respective acceleration due to gravity they are asking. So here G in terms of the capital density, the formula will be 4/3 pi into R into rho into G, you can take. Now here mass density, the two planets have the same average mass density. Density will be given as same. The ratio of the radii will be different. The respective acceleration due to gravity. So which means here G is directly proportional to R, you can take. So G on 1 by G on 2, you can take, which will be R1 by R2, you can take, which will be equivalent to, here you can take as 1:2 ratio. So now let us see the next question. The mass and diameter of the planet are twice that of the Earth. So here what will be the period of oscillation of the pendulum on this planet? So if it's seconds pendulum on the Earth, so mass and diameter of the planet, mass of the planet will be twice that of the Earth, and here diameter, which is directly proportional to radius, you can take. Radius on the planet will be twice of the radius of the Earth, you can take. What will be the acceleration due to gravity of the period of oscillation of the pendulum? Time period of simple pendulum formula will be T equals 2 pi into root over L by G. So here if it is a second pendulum on the Earth, so now here you can relate T is inversely proportional to, here you can take as 1 by root G, and here you can take as time period on the planet by time period on the Earth, which will be equal to, here you can take G, again here you can take as Gm by R square. So here you can take as M by, here we will be getting as R square, you will be getting. So here this root and this will gets cancelled. Here we will be getting as R by root M will be getting. So here you can take as R by root M. T is directly proportional to R by root M, you can take. This is the relation we will be getting. So radius on the planet by radius on the Earth into, here we will be getting as mass on the Earth by, you can take as mass on the planet, you can take under root. So here it is given as, so time period of the pendulum, seconds pendulum. For seconds pendulum, time period will be 2 seconds will be getting. Radius of the planet will be 2 times of the radius of the Earth by radius of the Earth, you can take. Mass on Earth by, here will be getting as mass on planet will be 2 times of the mass on the Earth. ME gets cancelled, RE gets cancelled. Here we will be getting as, so here when you are cross multiplying, here 2 2s are 4, 4 by root 2 will be getting. So 4 by root in the sense time period of on the planet will be, here will be getting as 2 root 2 seconds you are getting. Let us see the next question, students. The next question says, if the mass of the earth is increases by 2%, and here a radius of the earth is going to decreases by 1%, then percentage change in the g they are asking. So g equals to, here you can take as gm by r square, you can take, students, which is g is directly proportional to m by r square. For small changes, here we will be getting as, so delta g by g into 100, which will be equivalent to 2. So here delta m by m into 100. So here when it comes to the numerator, it becomes a plus value alone. Here 2 into, here you can take as delta r by r into 100. Delta m by mass, it is going to be changes by 2%, it's an increased value, that is plus 2%. 2 into, here you can take as, it's a decreased value you will be getting. So here it is, so this is, else here you can take as r power minus 2. R power minus 2 in the sense, here will be getting as minus 2 into delta r by r. Here this is one more procedure, students. Here we will be getting as minus 2 into, here we can take that this is minus 1% you can take. Here we will be getting as plus 2%, and here we can get it as this is plus 2%, which is nothing but we will be getting as 4%. So percentage change in the sense, here we will be getting as total g is going to be increases by 4% you can take. Now let us see the next question. The next question says here, the radius of the earth is decreases by 10%. Decreases by 10%, and here the mass remains unchanged, then the acceleration due to gravity is. So here radius is going to decreases by 10%, means here r minus here 10% means here you can take as 10 by 100 of the radius. So here you can take as r minus here this is 0.1 r will be getting, which is nothing but 0.9 r you can take. Now here you can take g is inversely proportional to r square you can take, students. Here you can get it as, this is g2 by g1 minus 1 into 100, which will be equal to, so here you can take as r1 square by r2 square minus 1 into 100 you can take, which is nothing but r1 square in the sense, here you can take as r square you can take, r2 square in the sense, here you can take as 0.9 r square whole square you can take, minus 1 into, you can take as 100 you can take. So here this is delta g by g into 100 you can take. So r square gets cancelled, 0.9 whole square means here we will be getting 0.81. So here we will be getting as, this is 9 by 10 you can take. So here we will be getting as 100 by 0.9 you can take as 9 by 10 you can take. 9 by 10 whole square means 100 by 81 will be getting, it's a minus 1 into 100. 100 minus 81 will be getting as 19 will be getting. So here 19 by 81 into 100 will be getting, which is nothing but nearly this value will be getting as 23% of g value will be getting. That means here it's an increases by more than 19% is the correct answer. And here the next question says, mass of the moon is 1 by 81 times of the mass of the earth is given. Mass of the moon is here 1 by 81 times of the mass of the earth is given, and the gravitational pull of the earth is given as, but gravitational pull is 1 by 6 that of the earth is given. So here you can take as gravitational pull on the moon is given as 1 by 6 of the gravitational pull on the earth is given. So the radius they are asking, g is directly proportional to, here we will be getting as m by r square you are getting. So here r is directly proportional to, r square is directly proportional to m by g, and here r is directly proportional to, here you can take as m by root g you can take. So radius of the earth by radius on the moon, which will be equal to mass on the earth by mass on the moon into, here we will be getting a g on moon by g on earth you can take, under root you can take. Mass on earth will be here you can take mass on moon will be 1 by 81 times of the mass of that, into here will be getting g on moon by g on moon is 1 by 6 times of g on earth by g on e. G gets cancelled, 81 me gets cancelled, then radius on the earth by radius of the moon will be getting as, here it is 81 by 6 will be getting 81 by 6 under root. So the radius of that is here 81 by 6 times of the radius of the moon will be getting. Now here you will be getting as a body is released from certain height and reaches the earth after t seconds. Time of fall for a freely falling body, the formula will be getting as t equals will be getting as square root of 2h by g will be getting. T equal to will be getting as square root of 2h by g will be getting. That means here t is inversely proportional to root g, you can take. So here g, when you are relating here, so if the same body is released from the same height on the moon, it reaches to the surface. Time on moon by time on earth you can take, which will be equal to g on earth by g on moon you can take here, which will be equivalent to time on moon by time on earth is given as t is given, which will be equivalent to g on earth by g on moon will be g of by 6. G gets cancelled, here time on moon which will be equivalent to, here will be getting as root 6 times of the t will be getting. So this will be the correct answer.